Okay, we will start now the third panel discussion with the marine microbes. I'm very happy to introduce Marga Drag, who is the moderator of this panel discussion, and she is the founder of the On-Country Innovation, that is States startup developing a game-changing technology to manage and control sea lice in salmonid aquaculture. Margaret recently stepped down as the EU chain of the Marine Microbe Working Group for the Atlantic Ocean Research Alliance between Canada, European Union and the United States of America. And she has also steering committee member of the Irish Ocean Literature Network. So please.
Thank you very much, Anne. Okay, I know that all of the past three talks with Erik Jan and Henk, and then finally with, forgive me, Ninfa. Excellent. I felt a personal connection with all of them, from the Ulva perspective right through to the potato, which is very important in Ireland. We'd be very concerned about our potatoes and the crops. And then finally, in terms of the aquaculture side and for instance, in terms of promoting and boosting the immune systems of salmon. So there's a lot of questions I have, and thank you very much to the panels for being here and volunteering. Now, I feel that we have one more panelist is coming in. So I would just like to start off maybe by each of the panelists introducing themselves. And I'm so sorry if you've already done that earlier today, but maybe Peppa, could you introduce yourself, Joseph Anton?
I'm a professor of microbiology at the University of Alicante. My relationship with the marine microbiomes is that we work on several marine systems, basically marine sediments, the microbiomes of some invertebrates like corals and ascidians. And recently we have been working also with Posidonia decaying, the plant decaying material, marine plant. We use metagenomics and other sorts of techniques, but this is my relationship with marine environments.
Very good. And we move on to, sorry, forgive my terrible pronunciation, Eftalia?
Yeah.
Yeah, okay.
Excellent, yeah. My name is Eftalia Arvaniti. I'm Greek, by the way. I live in Denmark for 16 years now. I am representing here the Submarine Network for Blue Growth. We are a network in the Baltic Sea region, a think tank and a professional network of a fair 50 members of private and public organizations. We are working for collectively for sustainable, promoting sustainable and innovative use of marine resources, and also coordinating the Mission Ocean, the Baltic Sea and North Sea Lighthouse. So very heavily involved in the anything that has to do with the aquatic and sustainability, and working with mussels and seaweed and fish, sustainable forms of aquaculture, marine biotechnology, and product development. So my background is in biochemistry. I don't have a microbiome background, but I understand that there's a lot of product opportunities for marine microbes also in agriculture. So
very good.
We'll see. Thank you very much.
Thank you. And Alexandra, maybe we'll bow to maybe Thomas online. Maybe I'll go to you next, Thomas, just to be slightly more inclusive rather than just to the folk here actually in the who are present.
Yeah, thank you very much. Thank you very much also for the invitation to this interesting panel and to these to be part of this final coming together of a very successful Horizon 2020 project. Yeah, my name is Thomas Richard. I'm from the University of Jena in Germany, and I'm an analytical chemist and biochemist working in the field of chemical ecology, and my research group is mainly interested in the interaction of ulva and its associated bacteria. So ulva is this green macroalgae, which becomes more and more popular. And starting with axenic culture, so this is a unique selling point of our group, we try to identify growth-promoting factors released by bacteria. And so we can test each individual bacteria on our actinic cultures. This is what we are doing. And we try to modulate also the metabolism of our host, of the algae, to improve, for example, the nutritional value. And we try also to understand the underlying functions which are involved in the reception and signal transduction of compounds released by the microbiome or specific bacteria. Yeah, thank you very much. And I'm looking forward for this discussion.
Thank you, Thomas. And finally, Alexandra Rodrigues, could you introduce yourself?
Hello, I'm Alexandre Rodrigues from Portugal. I'm innovation coordinator of the company Nectan. We produce microalgae for more than 25 years, mainly marine species, but we also grow some freshwater species. We have started working with microbiome, basically with SIMBA project, in a direct collaboration also with the University of Algarve that is nearby, and also with Tamara that is seated there. So we are quite new to this field, quite interesting field for us. We know that microbiomes have to do something to do with microalgae production, because we see so many differences in cultivation batches that we believe that microbiomes are doing something there. So yeah, thank you very much for the invitation, and I'm pleased to be here.
Thank you, Alexander. Actually, just before, if time doesn't allow, I would just like to say, for those who are actually doing any kind of research in this area but want to transition out to doing products, that they should really look at the European Innovation Council Transition Grant. It's 100% funded, and it helps you transition outward into becoming a company. And of course, collaborations, for instance, with Nectan and other type of companies is very much appreciated. The EU lead for the European Innovation Council for the agri-tech side of things is Ivan Stefanik. And while there was a soil microbiome recently, there was a call on this. There's equally calls throughout the year, and it's just something for you to be aware of. You may not be aware of the European Innovation Council transition or indeed Pathfinder type grants that could be of significant help, I think, to commercialization here. Okay, let me quickly move on. So we have quite a few questions here, and I'm going to intersperse them and hopefully to each panelist I'll pose the question, and it may or may not be your area of expertise, but you would have some thoughts and comments on it. So the first question I have here is, in general, for micro and macroalgae, how realistic do you think it is for commercial development and application of growth-stimulating bacteria mixes for large-scale culture or large-scale cultivation? Can you think of maybe the positive and negative effects for cultivation? Perhaps, Alexander, I can go with you, as you're already in the commercial space.
Yeah, as I already said, we believe microbiomes have something to do with the microalgae cultivation. And actually with this project we understood that we can improve the production and we can improve the quality of the product by changing the microbiome. So I think there is a huge potential here to make this viable at the industrial scale. We just need to understand some things, try to understand if it's possible to produce this microbiome at industrial scale. It's an important aspect that we are not yet sure, but I think there is a big potential.
And in terms of the timescale, how long of a timescale do you think it would require?
In the project, we have already did some trials at industrial scale. We have already identified a consortia of bacteria that were benefiting the algae. So if we move on, we could be using those bacteria quite soon. But yeah, we still need to tackle some issues with the industrial production of the bacteria themselves.
Very good. Okay. I pass to Eftalia.
Yeah, I can answer from my perspective that what I know is that the algae, microalgae specifically, or macroalgae as well, but specifically microalgae can be very good as a biostimulant for plants, agricultural plants, and we know that, and there are companies working towards that. There is a lot of course, as a first product, fertilizer, that is actually when you use circular nutrients, it's also very so you're using circulating nutrients for microalgae production, then fertilizer is the first product for mixed cultures. But the biostimulants is a great opportunity because it's an added value product, and we have better price in the market, but there are some regulatory barriers there, so we're trying to fix it. And the Commission also knows that they have to do some work because there are some serious barriers with when you have cyanobacteria, for example. You cannot use it for fertilizer. So I think this is what currently we are working with. So in this dimension, so we're helping the market access.
And when you take into account these kind of regulatory obstacles, shall we say, rather than blocks, how long do you think it could be? What kind of time scale?
To go to the market?
Yes.
10 years.
10 years.
Yeah,
okay.
Not so much. No, so much, no.
Yeah. Okay. Very good. And Josefa? Or Peppa? Sorry.
I don't have an informed opinion. I mean, but your question was whether we could use this bacteria for promoting the growth of the algae. I think if it's already used for plants and it wasn't that such a long process, it should. But it's just opinion. I mean, it's not science actually. So.
Okay, no problem. And Thomas, I don't know whether you can speak to that.
Yeah. So there's not so much data available that bacteria really promoting growth and the development of macroalgae. Many groups are working on that, but one of the biggest issues is how sustainable is this new interaction between beneficial bacteria and the macroalgae, because the most systems are open pond systems. So if you add your inoculum to your macroalgae or into your macroalgae culture, so you have to be sure that these new microbiome or specific bacteria are maintained in these aquaculture. And if you have an open system, so there is a dilution effect. So from that point of view, you have to understand very well the interaction between the macroalgae and the bacteria, so that the bacteria are really dependent to some extent from the macroalgae. So you can do that, for example, by understanding which kind of carbon sources are necessary to feed these bacteria and provided by the macroalgae. And then, if you are lucky, you have some of these bacteria which are depending on these carbon sources, which actually are feeding the algae with growth-promoting factors, for example, hormones, which we have identified in terms of bacteria macroalgae interaction. So it is, I think, in a closed system, you can benefit from that, or you can create a bacteria promote or algae promote a growth promoting system through bacteria in a better or easier way than in a huge pond system, which is an open system. And I think in aquaculture, algal aquaculture, people are going into this research field now to understand how sustainable is a designed microbiome in an open system. Yeah, thanks.
Very good. And actually, a thought occurs to me in terms of macroalgal culture and the biostimulation and of this growth, basically, but more for a circular economy rather than for a food product or a product that actually ends up in the body, for instance. Can you see applications in terms of the circular economy with the macroalgal production, Thomas?
Circular production in terms of So we have a benefit for food and other things at the same time, or something like this?
Well, more for instance, the production of bioplastics and that type of thing, you know, helping the macroalgae to grow, getting a bigger product, a bigger biomass in terms of applications perhaps in bioplastics or other products.
Yeah, indeed. We have to distinguish between these high quality products, which are very, which have you can make a bigger profit from, and those bulk stuff. And Eric mentioned already, there is right now another EU project. It's called Cost Action. There's a specific working group which is working together with SMEs, with small companies, to use macroalgae for the development of bioplastics and these kind of things. I think this is a very good opportunity to make these algae valuable for our market, rather than hoping on a very specific compound which can be used for pharmaceutical applications. So I think biofuel, bioplastics, and of course feed for animals, that are the most reasonable applications in the near future.
Very good. Thank you, Thomas.
And but also you have to think about bioremediation, because macroalgae in general are very good in very resistant to micropollutants. They can even decompose them together with the bacteria, so the water is clean. The algae is at the end not contaminated because these compounds are decomposed, so you can still eat them or feed them to animals. So there are a lot of applications possible.
Very good. Eftalia, I can see that you want to come in.
Yeah, there is the circularity of algae is very important here, and that's why we are talking a lot about algae. And Eric Jan presented the algae initiative and the EU for algae, because there is a huge need for sustainable recyclable solutions, and algae, macro, bring this to the map of biomasses, and also using the sea and the water resource for that. And there is a substantial palette of products we can use: food, feed, cosmetics, biomaterials, fertilizer, biostimulants, and fuels, of course. And EU4Algae is having also, like Thomas had, the URVA project, the construction. EU4Algae has also 7 working groups, and if you haven't registered to the EU4Algae, I really hope that we will have also all of you on board, because with stakeholders we can do a change. The Commission is waiting for you all to bring your barriers and suggestions so they can do change and support this sector. When it comes to food and feed and circularity, I was last week in Brussels in the European Sustainable Nutrients Initiative, and we were talking about circularity and microalgae for food, feed, cosmetics, and also biostimulants. Of course, there is a lot of barriers, again, regulatory barriers, and of waste definitions, and what is a bio-waste, what is a wastewater, what is a side stream, and stuff like that. So circularity is an obstacle, and right now there's a lot of work also from the EITIP, European Aquaculture Technology Innovation Program, that they are talking about sludge, they are talking about circular nutrients, enabling the sectors. Basically, we haven't close the circle, okay? Regulatory-wise, we can do as much from the technology, but the market access is blocking. Yeah. So we have a lot of work also with the Commission and the different parliaments, you know, a lot of activities going on that. So,
very good. Initially I thought that, okay, if there's one, obstacles in one way, there can be another path where one can be advancing at the same time, and then once that regulatory path begins to loosen and it begins to solidify, basically, you can take your what has advanced here and reapply maybe in the other area. Alexander, I don't know if you have any thoughts on that as well.
Yeah, I think the algae are very good for this circularity issue. We can use the side streams of the production of algae also to use and use them in other for other outputs. I mean, we can use a part of the algae for cosmetics, another part for plants, and with this we can even close different loops, and then we can grow the algae with effluents from other industries. So algae are really perfect for this kind of issue, and might be a solution here for to close the loops and use resources from other industries.
Very good. Okay, but perhaps not used for feed and aquaculture. I don't know in terms of the regulatory side of things there. Nifa, in terms of using waste byproducts from one process to grow macroalgae or even indeed microalgae for another purpose, for instance, for feeds and that type of thing. But no, okay. All right.
Yeah, actually, if I can add, we have a project where we will grow algae, for instance, spirulina, that is food approved, in water from greenhouses that grow berries.
Very good.
So that water has some nutrients that the algae can grow on them. We are not sure if we can sell the algae as food, although the water comes from a food production facility. So,
yeah, okay, I see the difficulties.
Yeah.
Okay, very good. Thomas.
Yeah, I like to add, so I think for organic compounds and micropollutants, there are several groups working on that issue right now, and macroalgae, and particularly ulva, might be a good solution in getting rid of these micropollutants, for example, bisphenol A, BPA. But at the same time, ulva is not contaminated by these compounds. Yeah? So this is a very interesting observation. Several groups have done that, and maybe we can use actually ulva for wastewater treatment. And at the same time, we can use it also for other products for human beings or for animals. This is not true for heavy metals. Heavy metals are usually accumulating in these macroalgae, and this is a bigger issue. I think one has to distinguish also how the water is contaminated and what do you want to achieve. Thanks.
Very good, a good caveat there. Okay, I'm going to move on to the next question I have here, which is, do you think there are risks involved in deploying or modifying these microbiomes? And could you identify these? I'll pass straight to Alexander.
yeah, maybe I can start. In our specific case, where we selected microbiomes to help microalgae to grow, we isolated many bacteria that were already present in the water where the algae grow. And we then identified some bacteria that the indication was that they would improve the growth of the algae. And in the end, they did improve the growth or the quality of the algae. But basically, those bacteria were already present. So we are quite safe to say that there is no risk on using those because they were obtained from that water. But it's something that we also still need to study if it's totally safe to inoculate a culture of algae with a lot of bacteria. What we also observed is that by inoculating the algae with those bacteria, we see that the numbers of the bacteria maintained. So there is maybe an indication that that consortium of bacteria is maintained, but we are not sure about this yet. We are analyzing the different time points to see if there is changes in the bacteria, but at least the level of bacteria is maintained. Comparing with the control, that then it's starts with 0 and goes up quite a lot.
Very good. Okay, and actually I spoke with Henk earlier, and Henk, I said to him, did you taste the potato? And he said no, because of the whole risk of the inoculant causing a problem later. So it would be the same sort of thing here. No one gets to taste your product, or do they? At the end, simply because of the regulatory risk that somebody could get, well, it's not just regulate, it's a health and safety thing, that someone could get sick.
The trials we did were with chlorella, so it's food approved. We could easily taste them. I don't know if Tamara tasted them, but
no?
It's actually one of the bacteria is expected to improve the B12, the vitamin B12. So I believe it's just one. I'm not sure, but the three. Okay. So we are also targeting here a need that we know that the chlorella will be better if it has more B12, mainly for the vegans. So it needs to be food safe, but we will check it.
Okay, very good. Peppa. Yeah.
Regarding what you ask about mixing microbiomes, I think sometimes it's extremely difficult to know in advance. And I, as I told you, I don't work with algae, but we did some experiment with corals, and using like autochthonous bacteria isolated from the place. When you two species of Vibrio which were not pathogenic at a given temperature, they were pathogenic when they were mixed, and we saw that the virulence was due to the interaction. I mean, it was like a side effect, and this was extremely difficult to anticipate. So I think that there's always a risk, but that's something that you can measure, actually. I mean, I don't know in another system, but it was a very simple system, just one.
Very good, yeah.
So
and of course...
microbe and the natural microbiome plus this.
But I guess with corals, there's kind of like a chemical warfare going on. So perhaps the mixing,
So they should have more defense for the mixing, but this was just the interaction. I mean, there was not like the bacteria were pathogenic. I mean, the virulence factors were expressed because of the presence of the other bacterium, not because of the presence of the coral. So the interaction was causing the disease. So maybe, I don't know in algae, as I said, but I mean, there is always a risk, but a risk that can be measured somehow.
Yeah. Okay, very good. Mixing causes, okay. So big caveat there in terms of the mixing. Beware the effects that can be produced. Obviously, it needs to be studied. Another question there. Thomas.
Yeah, I think we are changing the balanced microbiome to the favor of a specific product in these cases. And we have to really distinguish between the laboratory system or a company system, which is a controlled closed facility, or we do that in an open system close to the coastline. Because then we might have also an imbalanced situation in the coastline, so which might lead to an ecological disruption, or we can also favor a pathogen which is showing up through this imbalanced system. And of course, we all want to promote growth, very often at least. So that could lead us to a biological control issue, because bacterial mixes could promote excessively algal growth, leading to the issues like a green tide in the coastal area. So these things are not predictable, and I think earlier or later we will be confronted with these kind of things.
Very good. Okay, thank you. Yeah, Eftalia.
Just a small comment. I'm an outsider of the microbiome, as I said. I'm not a specialist here. But hearing all these discussions, I need to say that for upscaling micro and macroalgae biomasses for product development, we need standardization in order to bring it to what Eric mentioned in the beginning, that we have to have thousands of tons, increasing from 100,000 to 10 times or 20 times more. what we are producing in the next 8 years, we need standards. So no matter what is the microbiome, what is the conditions you're using, internal, external, it should be a standard biomass coming out in order to be processed further down in the product development, to have a client that will be expecting day in, day out that they will get a specific product out of your farm in order to process it further for products. And for bioactives, for pharmaceuticals, nutraceuticals, this is very important. Yeah.
Okay.
But that is tricky for microalgae production outdoors. We work with the seasons, so we know that the biochemistry of the product changes throughout the year, or even sometimes if we harvest in the morning or in the end of the day, there are differences. But yes, we understand that most clients want a standard product. We always say that there will be variabilities, there will be changes. Like we have in foods from agriculture. Sometimes the tomato is better than other times.
Yeah, very true, very true. And I believe in some of the talks there earlier, the distribution and the changes within the actual microbiome itself is changing over time, while maybe the species, the number of species isn't changing, but the actual distribution on numbers is changing over time as well, of course. Okay, so how will the efficiency in animal feed production contribute to overall sustainability of the sector? I'm wondering if I could hand that over here to Alexander.
Sorry, can you repeat?
The question is, how will the efficiency in animal feed production contribute to sustainability of I guess, the microbiome side of, the sector in terms of using microbiomes? Do you think the animal feed type production, perhaps using microalgae, and that could begin to perhaps stabilize or not the sector?
Yeah, we know there is, and here we are speaking of microbiome. We all know that there are different kind of microbiomes. If we speak of the microbiome of the gut of the fish, we know that there are studies that are trying to check it and to use ingredients that lead to a better microbiome, lead to a healthier fish. The algae, micro or macroalgae, are good options for such kind of ingredients because they can be immunostimulants, so they can make the fish healthier, and this will, of course, affect the gut microbiome of the fish. So, yeah, I think that there is still quite a lot of improvements to be done in the feed industry, as we saw just in the previous presentation. There is still a lot of things to do, also to increase the sustainability of the feed industry.
Very good. I don't know if anybody else has any thoughts on that particular question. No? No? Dalia?
Yes.
Oh, sorry, Thomas.
Yeah, certainly. If we are succeed, actually, I'm confused with my Zoom right now. Sorry for that. So if we succeed to modify the microbiome, yeah, let's hope we get that, and then we get more and easier and better quality of algae for animal feed, and this food is then contributes to an efficient feed production. Maybe this can also lower the land use. So this is also the idea, I think, of this. So efficient feed production can produce higher yields per unit, and good food or feed can contribute to this. Or the algae, I think Eric had that on his first slide, is contributing to reduce greenhouse gas emissions by the animals. So all these things might be linked to a good feed. The feed are the algae, and the algae are benefiting from the microbiome. I think this is the selling story from the phycologist working with bacteria right now. But all these things has to be proven.
Yeah. Can you think of a time scale there, Thomas, for you know?
I mean, in our laboratory, that takes a couple of years, but then we need to scale it up. I think in our very small community, which is not very, one has to say that we are not very charismatic. So we are not selling things, let's say we are going to the Mars soon with this idea. So I think things can work, but it takes too long because we are too few people involved in this. And there's too less competition in this field for ideas. And for that reason, I'm a little bit pessimistic. I think this can still take decades.
Okay, very good. Okay, that is pessimistic.
I mean, people had these similar ideas already in the 80s.
Yes.
So this is not new what we are doing, actually.
Yeah. So I think one of the things actually that I really liked about the Ocean Decade was that they really took on something called ocean literacy. And that was all about teaching the importance of the ocean. And in a similar way, we need a microbiome literacy, informing people about the microbiome, whatever type, there's microbiomes everywhere, and that just to bring that message across and inform people. For instance, if I'm out in my garden and I want to have luscious plants and things, I would be very happy to take, any microbiome that makes my garden look fantastic, but I don't necessarily want to know everything about that, So, yeah, Thomas.
Yeah, exactly. But for example, I mean, microbiomes are already used. For example, people are buying yogurts with a specific proactive microbiome inside. Yeah? So people are aware about that. And I think in some branches of food industry, and also I'm very optimistic that in human health issues, this can be quickly solved. And also we have some products on the market, but we are talking now specifically about algae, and can we improve algae with a specific microbiome, and then algae become a better product? And here I'm a little bit more pessimistic.
Okay.
Because the community is too small, particularly in Europe. And in Asia, people have another approach, because these algae are just growing all over the field. They just harvest them from the ocean, or in the bays where they are allowed to grow them. But in our case, we are much more, in Europe, we are much more restricted. Either we have to do it land-based or in very small districts and in the coastal line. So I think we don't get the amount which is necessary to be successful economically. But that's just...
Okay.
I'm not educated in that so much.
Yeah. Okay. Very good. Yeah. So certain obstacles in terms of the how do you say this? The rules in Europe, basically, that limit our ability to.
Yes, and we are also not. We don't have so many green tides just in front of our house, right? So like in China, for example, in the Yellow Sea, there are every year massive green tides, and they can just collect these algae and use them for cheap bulk products.
Okay. Okay, very good.
For animal feed, for example.
Okay, thank you, Thomas. Eftalia.
The ambition from this European Commission for the EU Algae Initiative is that we will become an upcoming industry in Europe to place ourselves equal next, in the future at least, to other world players. So Korea, Japan, China, and Vietnam, and so on. So that's the deal. To succeed to go there, especially when it comes to feed, we need to understand, first of all, what the client needs. So we had a very nice example here from fermentation experts, like efficiency, like we have half of the amount of soybean, they have the same growth, which is great.
It's fantastic, yeah.
Then when we are talking to them for algae, we get that the price is a barrier. So commodities for feed are very specific. There are about 100 different ingredients when you have a feed composition, and the price is the king here. So if we don't get the price, they will not interested in this. The battle between that is to have additives, not ingredients, but additives. So we have added value products with a small content, with still an amount, we have a great result. In that way, it could be the way to go forward, possibly, with bioactives.
Okay.
For replacing some of the feed.
A kind of supplement to feeding.
Like biostimulants, but for animals.
Yes, for animals, yeah. Okay, very good. Okay, Peppa, I don't know if you want to come in there.
Can I ask a question? But can you use like the algae genes for, I mean, instead of using biomass that we can compete with other people, we can look for the genes involved in things and use these genes to produce the things? You know what I mean? I mean, instead of purifying the compounds, making it in vitro by... Is it possible? As in this initiative is also contemplating the use of the algae genes, not the biomass itself, just because they have something in the genomes that now no one else has in the world, right? For sure. And so you can mine, do gene mining instead of biomass collecting. It's just a crazy question.
I think we are starting with the low-hanging fruits here. So we are looking at what species the European citizens have been consuming. So what is new food, new algae, and so on. And so we're starting from the natural. There have been some discussion about GMOs, but... this is not modified. Okay. This is just purified. Purified.
Not about GMOs.
Okay. Yeah.
Yeah.
I think I'm not an expert here.
But what I can add there is, for instance, omega-3 fatty acids that the algae are very rich on. It's a quite complex pathway to make the omega-3, so it's different genes. Yeah, yeah. It's tricky to put all those genes in a yeast or whatever.
Yeah, sure. Yeah, that was what I was
asking. No worries.
I shouldn't be asking here.
Yeah, it's very good because it brought to mind the genetically modified organisms and everything, and in Europe it's a big no-no, but in other countries not.
But this is not
much.
Genetically modified organism.
No,
it's like
producing
recombinant things. That was just a crazy question. I think that's just
very good. And I know that Anne is going to come on down here and cut me off any second. So I would like to thank you all, Thomas and Peppa, Eftalia and Alexander, for your kind answers and thoughts on all of these questions. I think afterwards we do have a few more questions that we never got to. So perhaps the individuals who posed those questions could come up to the panelists separately afterwards. Thank you very much. Anne. Thank you. No. Thank you very much. Thank you very much. Thank you. Very useful in Ireland. Yeah. Thank you.
Okay, thank you for all the panelists and the moderators for this day, and I think that it is now time to wrap up and close the meeting. It's like a very sad time for all of us to end this project. We just remember that when we planned this project, it was also in Copenhagen. That time it was at Copenhagen airport where we made the plan for this project. So this is quite like a coming circle is closing now and having this final meeting here. So thank for all the partners for the great work you have done. And as we had heard today, there is still a lot to work. I think that there should be several projects to fill in all the gaps that there are still for the microbiomes from different sources, and also to get the consumers and different stakeholders to use also the microbiomes. So there are cost effects and regulatory aspects, some social aspects. There are a lot of different things that has to be done before they are at the market level. But we have given a lot of new knowledge to the stakeholders. What kind of microbes there can be used for different sources. Especially we have got a lot of information on the plant production and also food processing, and both for plant and seaweed. So there is a lot of new information, and I'm sure that there will be a lot, especially on the marine microbes in the coming years, a lot of new potential for those to be used in several applications. But finally, I would like to thank for the partners for their contribution to the project, so that we have achieved a lot of interesting results. That next we have to report them, but that comes then later. And also the panelists that has been today and the moderators who have been very active, and also very much thankful Tim and his team for organizing us this meeting. So with this word, I would like to thank you all for this wonderful meeting, and that's where I end. Thank you.